Hello and welcome everyone to our next lesson, which is the definition of derivative. Now, what is a derivative? Now, this might be the first time you guys have heard of this term derivative, if you haven't learned it before. So, a derivative is nothing but simply the slope of tangent. It is the same thing and the same concept as a slope of tangent or the instantaneous rate of change. It's just another name given to it. So here's the definition of a derivative. So let me just go through this. A derivative of function f at a number a is given by the formula this, provided that this limit exists. Now, there are a couple of things that we need to talk about. So the first thing is this is how we are going to denote a derivative. So if we have a function y, the derivative would be a y prime. If we have a function f of x, the derivative is going to be f prime x. So that prime denotes our derivative. And then let's just write down the formula which defines derivative, which is limit of h going to 0 of f of x plus h minus f of x divided by h. Now, they have used a as the number, but we can use x. It's the same thing. So what does this formula mean? Now, if you guys remember from the last lesson that this part of the formula is the same formula that is used to find the instantaneous rate of change. So we used that formula and we had the value of h given to us as 0.001. So this value of h brings us to this limit notation. This limit notation basically means the value of h is not exactly 0, but it is very close to 0. If we go back to our lesson where we learned about the basic concepts of limit, we learned that whenever we have a limit notation of anything going to a number, that means that it does not equal that number, but it is close to that number. So over here, the limit of h going to 0 basically means that the value of h is very close to 0, which we learned in the last lesson, h is equals to 0.001. So that's what this formula is all about. We have the limit of h going to 0, which basically means that h is equals to 0.001. And then we have this part, which is the same formula that we used to find the IROC. However, in this lesson or from now on, we're not going to use h equals to 0.001 anymore. The reason I'm going to explain you later. Instead, we're going to use this notation. So I'm going to show you an example where we're going to use this formula to solve for the derivative. So let's take a look at this example where we have, they asked us to find the derivative of the function f of x, which is x squared, at x equals to -3. So this basically means that they asked us to find the slope of the tangent at x equals to -3. Now, if I have to represent this whole question in a graph, it would be something like this. So let's draw a graph. Let's have the x-axis and the y-axis over here. So that's my y, that's my x. And if I have to draw the x squared graph, it looks like that. That's my x squared function. And that is, let's say, -3. And if I go up over here, that's the point where my tangent line will cut the graph. Now I just have to find the slope of this tangent line. So how do we do that? We are going to use our limit formula. So limit of h going to 0 of x plus h minus f of x divided by h. So I'm going to break it down step by step. So let's first do f of x. So I know my f of x is x squared. Um, x is negative 3, so we're going to find f of negative 3, which is going to be negative 3 squared, and that will give me 9. Let's now do this part. So f of x plus h. So that is going to be f of negative 3 plus h. Now, as I have mentioned that we are not going to use a value for h, so we will have to keep h as the variable h. So we're going to keep that and then simplify this. So technically, we just have to plug in negative 3 plus h into x in the function. So we're going to have negative 3 plus h whole square. Now, to simplify this, we have to use our formula a plus b whole square. And what is a plus b whole square? A plus b whole square is equals to a square plus 2ab plus b square. We're going to use this to simplify this, where my a would be negative 3 and b would be h. So let's do that. And so we are going to have negative 3 whole square plus 2 times h times negative 3 again plus h square. So if I have to simplify further, this is going to be 9 minus 6h plus h square. So now I have f of negative 3 plus h, and I also have f of negative 3. So we're going to put all of them together into the formula, and we're not going to put the value of h as 0.001. Instead, we're going to keep h as h. So to do that, let me just write it over here. We have 9 minus 6h plus h square minus f of x, which is going to be 9 divided by h. Now, a very important point over here. We cannot just write this like this. We always have to write the limit notation on the side, because without that, this makes no sense. This will denote us that h is very close to 0. If I don't write this limit notation, this equation makes no sense because we do not have a value for h. So now we have this. If we want to simplify, all we have to do is cancel out the 9's over here, and then we are left with limit of h going to 0. I will be writing the limit notation in every step, and in the function I have negative 6h plus h square divided by h. Now when we reach here and we know that the value of h is very close to 0, we can just estimate that h is equals to 0 and plug it in. But if we plug it in this function, we will not have an answer. Why? Because we cannot have 0 as the denominator. If 0 is a denominator, the function is undefined. So what to do? So we're gonna simplify it a little bit further. So let's move like this. So I'm gonna write this again. And if I have to simplify, I can factor out h. So if I factor out h, I am left with negative 6 plus another h in there divided by h. And now I can simplify by canceling out the h. So I'm left with limit of h going to 0 of negative 6 plus h. Now that I do not have anything that will make my function undefined, I can just directly plug in h equals to 0. And that will give me my slope to be -6, which makes total sense because if you look at the diagram over here, we can see that the tangent line has a negative slope. It's going downwards. I know this is a little messy, but I will post this whole class note as an image so you guys can keep track while you're listening to the lecture as well. So I'll just point it out like this so that you guys know which way to follow. I'll just put arrows. Just trying to be a little bit fancy. Okay, so that's basically how we find the derivative. And obviously at the end we are going to use the derivative notation to show that it's -6. And you can replace this x as -3 as well. So that's it. I will show you another example, but which is already solved actually. So let's take a look at this. I'm going to explain you guys. Determine the derivative of the function f of t. So now the independent variable is t, and the function is square root t, where t is greater or equals to 0. So they asked us to find the derivative of the function f of t. Now note that they have not given us a value for t. They did not ask us to find the slope of the tangent at a given value. Instead, they just asked us to find the slope of the tangent in a function form. So let's do that. So we're going to use the same formula again. And we're going to break it down. And that would be an easy way to do it. So in this case, my f of t would be square root t. F of t plus h would be square root t plus h. Now if you see that, all we did over here was we plugged these in over here and then we simplified it. Now how do we simplify a function like this? Let's go back to our first lesson where we learned rationalization. To rationalize an expression like this, we need to find the conjugate. So we have our radical expression that has a conjugate of square root t plus h plus t. So you can see that we multiplied and divided it over here, and then we simplified it. So in the bottom we have h times the conjugate, and on top we're using the difference of square formula to get t plus h minus t. And then we can simplify it further. We can cancel out the t to get h over this, and then we can also cancel out the h to get 1 over square root t plus h plus square root t. And not to mention, there is limit of h going to 0 all through. So that means we can now plug in h equals to 0. So we end up getting 1 over 2 square root t. Why? Because there is 1 and then there is 1 square root t. We can add them up to get 2 square root t. And that is my derivative function for this function. And in other words, we can say that this function is used to find the slope of the tangent line. So whatever value of t I give you, so let's say I give you the value of t to be 2, all we have to do is plug in t equals to 2 over here in this function to get the slope. So that's pretty much it for derivative. So as I have explained what derivative is, and now we also know one method to find the derivative of any function at a given point. So thank you very much for joining in, and I'll see you in the next lesson.